Welcome to our lesson on dividing fractions. So the first thing that we're going to do is we're going to take a look at some picture examples in order to try to identify a pattern. We're going to try to formulate a rule for ourselves that we can use every time that we are dividing fractions. So what I have for you is a list of different questions. As you can see, the first question says 6 divided by 1/2. Now, the way that I think of this, because decimal division is very confusing, the way I think of this is pretend that you're working in a bakery and you baked 6 cakes. 1, 2, 3, 4, 5, 6. And you show them to your boss. You're really excited to put them out for sale. And your boss says, no, those are way too big. You need to cut them, divide them all in half. So in other words, you take your knife and you divide this one in half, this one in half, this one in half, and we divide all of them in half in order to sell some smaller cakes because he thought that one was too big. Now, if you take 6 cakes and divide them in half, how many cakes do I have now? Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 6 divided by 1/2 is actually 12, which is surprising for some people because usually when we think of division, we think that the number is going to get smaller, but what you'll find is that with decimals and fractions, that isn't always true. All right, next question is a very simple one. What is 6 times 2? Obviously, the answer to that is 12. All right, next part. Let's say we were at the same situation. We baked 6 cakes. We were super excited. We showed our boss, and he decided they were humongous, way too huge. He said, actually, divide those 6 cakes into thirds. So we divide each one into thirds. Each one's being divided into 3 equal or seemingly equal chunks. Now, if I were to actually take a cake and divide it into thirds and sell it, I would have 3 pieces to sell. So here I have 3, 6, 9, 12, 15, 18 pieces of cake. So 6 divided by 1/3 is 18. Now, similarly, we have another easy question. 6 times 3, 6 groups of 3 would be 18. Our final question is a little bit more confusing. Let's say that you baked the 6 cakes, but this time your boss wasn't too mad. He just said, you know what, they're a little bit too big. We're going to group them into sets of 2/3 and then we're going to sell them. So in other words, you would have to group them into sets of 2/3. So again, I'm going to have to, chop them all into thirds. And what I would do is I would sell these 2/3 as one cake. And I would push these two sized, that's 1/3 and that's 1/3. So these 2/3 would push together to be a cake. These two are another cake. These two are another cake. Here we have another cake. These two make one more. And we're going to keep going until we run out of cakes to use. So there we have it. We've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 cakes to sell. So in other words, 6 divided by 2/3 must be 9. Now let's do a problem. It's not that simple, but it's a lot easier than the other ones we were doing. 6 times 3/2. Now I see that I can cross reduce. 6 and 2 have a common factor of 2. 6 divided by 2 is 3. 2 divided by 2 is 1. 3 times 3 is 9 over 1 times 1, which is 1. 9 over 1 reduces to 9. So the most obvious pattern that we see is that the answers are the same. This question, this question. The answers are the same here and here. The answers are the same here and here. Now that's a little bit too obvious. I want you to pause the video for a moment, and I want you to think about what pattern I was hoping that you would try to find. All right, hopefully you noticed the same pattern that I did. What I noticed is that you get the same answer. You get the same answer if you divide Or, so this whole column over here, let me get my pointer out. This whole column over here was divide. We got the same answer if we had changed the problem into multiply, but the trick is 1/2 became 2 when we were multiplying. 1/3 became 3 when we were multiplying, and 2/3 became 3/2 when we were multiplying. So we didn't just turn the problem into multiply. You get the same answer if you divide or if you multiply by the, and let's think about what that is. Basically, 1/2 flipped around is 2, 2/1. 1/3 flipped around is 3, 3/1. 2/3 flipped around is 3/2. So what we're doing here is we're multiplying by the reciprocal. A reciprocal is a number basically flipped around. Its numerator and denominator are flipped around. So 1/2 flips to 2/1, or 2/3 flips to 2/3. So instead of having to draw all these pictures and figure out slicing and things like that, what we can do is change any division problem into a multiplication problem, and we're going to multiply by the reciprocal. So we have to change two things. If we change it to multiply, we have to flip the second number to make it its reciprocal. So let's go ahead and try that. Now we already know that when we multiply, divide, even add or subtract with mixed numbers, we should make them improper. So I'm going to go ahead and do that. 5/2, 5 times 2 is 10, plus 1 is 11. So this would be 11/2. And instead of divide, I'm going to say times, and I'm going to make its reciprocal. It's reciprocal. Okay, the next thing I'm going to do is check for cross multiplying. 11 and 1 don't have anything in common, but 2 and 4 do. 2 and 4 can both be divided by 2, so that would become a 1. That would become a 2. 11 times 2 is 22. 1 times 1 is 1, so my answer here is 22. If I had 5½ cakes and I split them all into sizes of 1/4, I would be able to share with 22 people. I'd have 22 little slices to share. All right, let's go ahead and take a look at the next problem. This gets a little trickier. I'm going to have to go ahead and make this whole thing improper before I do any sort of multiplying by the reciprocal. Sometimes people try to do too many steps at once, and usually it results in a wrong answer. So I'm going to ask that you do things one at a time. 2 times 2 is 4, plus 1 is 5. So this is 5/2. And again, I'm doing just one step at a time, so I'm going to leave it as divide for now. 3 times 2 is 6, plus 1 is 7. Now, division is hard, so I'm going to now change it. Now that I'm in a correct form with just regular fractions instead of mixed numbers, I'm going to multiply by the reciprocal of the second number. So the first number always stays the same. I'm going to multiply by the reciprocal. Again, it's smart to look for anything you can cross reduce. 5 and 7 unfortunately don't have anything, but 2 and 2 both reduce to 1. So now I'm left with 5 times 1, which is 5, over 1 times 7, which is 7. And that's my final answer. Again, I don't need to do any other additional flipping or anything like that. So let's go ahead and before we end our session on division, we'll review the algorithm. First step, always change any mixed numbers or whole numbers into improper fractions. And we know that we need to do this when we multiply, when we divide, usually when we subtract, and sometimes it's just good to do it when we add also so that there are no silly errors. But it's especially important in division. Change any mixed numbers to improper. Second step, change the division problem to a multiplication problem. But we also have to change the second number. We have to multiply by the reciprocal. Third step, multiply like normal. So we're going to do the top times the top, bottom times the bottom, and then if possible, we will simplify. Thanks for listening. Have a good day.